Okay, the quiz is straightforward, easy. You already had this before from machines and circuits. And there will be maybe one question or two for the to do maybe calculation, simple calculation. You don't need you need a simple calculator to do a simple calculation. Okay. All right. So we'll start the transmission line parameters, and this will be part of the midterm exam, which is 3 weeks. So please focus on this part, the transmission line parameters. Please focus on this lecture. So what this is, of course, the textbook that we adopted is the one here. I encourage you to have this book here, the 6th edition. And the software that we use is by the authors. The software that we use in the lab is given by the authors to students. So it's available to students. Some utilities, they use the professional, by the way. The professional that you do more functions and more buses. We do thousands of buses. And some electric utility, they use the Powerwall simulator. Okay, so the book, the software that you use in the lab is an educational part, but it is it's used professionally in some utilities, electric utilities, when they do power flows and short circuits analysis. So what we want you to focus today is to determine the parameters. So we have a number of parameters for overhead power lines. These parameters include resistance, inductance, capacitance. Okay. Now, before we go on to determine the parameters, I would like you to see to be familiar with the transmission lines itself. Now, this transmission line has a tower, and this is made of steel, which is a conductor. It's made of steel. The wires you can see on the left here and the right here, the transmission lines here, are connected to insulators here. So this is the insulators. And it's made of porcelain or glass. So this insulates the tower, which is a conductor, from the overhead transmission line, which is also a conductor. The overhead transmission lines are not insulated. They are open to air. So the open to air means that it's cooled by air. So there's no insulation around, like what you see in your house. The wire in your house is insulated from outside, so you can't touch it. But these are not insulated. Okay, so it is cooled by air. And they are insulated from the tower, which is a conductor also. It's made of steel, by the insulator here. So the purpose of the tower is just to suspend the transmission lines. Also, you can note in here, in each side we have 3 phases. 1, 2, 3. 3 phases: A, B, C, or red, yellow, blue. On the other side also we have another circuit, A, B, C. So this tower here is a 2-circuit tower, a 2-circuit transmission line. Also note here, on each phase we have 2 transmission lines, 2 cables, separated by spacers. These 2 transmission lines, separated by spacer, they are called bundle conductors. Bundle. So this is a 2-bundle conductor, a 3-phase, 2-circuit, 2-bundle conductors. So the 2 wires here is in 1 phase, but instead of having a big cable, that we can have two small cables, but on the same phase. So these are on the same phase. So these, we have 6 cables here, you see, or 6 transmission lines in here, but we have 3 phases because for each phase we have 2 cables. Why we have this one? To carry more power. Otherwise, the cable will be huge, will be large. So to carry more power. Therefore, we'll have 2 bundle conductors for each phase. And this is another circuit, of course, same voltage. Another circuit also carrying to the same substation. So it goes both to the same stations. Okay. What else now we can see? And these we call them spacers. Earth wires also, you can note here at the top. We have earth wires at the top. This earth wire touches. You can see there is no insulator here. It touches the tower, because any current on the wire can pass by to the tower down. Okay, so this is pass by to the tower. Now this earth wire here, which we use it, is always at the top, not at the bottom, not in the middle, always at the top. Why? Can I ask you why we have these at the top? The earth wire is at the top. Yes, Abdulaziz. Yes. Go on. Yes, Abdulaziz. Why? Why? We cannot. Okay, you can write, just write the chat. If you cannot hear you, you can write on the chat. Okay, or anyone can write on the chat why we have transmission lines. You can see your chat. All right. You can write on the chat, Abdulaziz. You don't need to. Okay, we cannot hear you. Thunder, okay, good. So that protects the wire from any lightning, to protect from lightning. Good. Okay, so to protect from lightning if the thunder hits. Okay. Sawa'iq, so this protects from lightning. Where you have this? Where do you study this one? Where do you study the transmission lines? In what course? You read about it? Okay. In electromagnetics? Okay. All right. And, okay, that's good. Very good. Okay. So we have 4 of 3-phase lines. Their transmission system. 4? What for? For what?
Doctor, you said each side has 2
bundle conductors, or 2 circuits. 2 circuits, yes.
Yes.
One circuit here and another circuit here. ABC on the right, also ABC. And once this tower is going to the substation, so we ask the tower to carry another transmission line. That's okay. So buy one get one free. Sorry, buy one get one. It's like that. So the tower is going to the transmission line. It carries 2 instead of just carrying 1 circuit. It carries 2 circuits. That's okay. On the right and left. Yes. So what's your question?
Yes, doctor. But you said that we have 2 wires in or per circuit. So we have total 4, right?
Total 6. 2 wires, not 2 wires. 2 wires on each phase. We have these 2 wires here, and there are also 2 wires here. Okay. So in each phase we have 2 wires. Bundle conductor, called the 2 bundle conductor.
But they are going to the same substation, right? Or
of course. No, of course. No, of course, to the same substations. This tower here will go on one way to the same substation. Okay, so this will go to the same substation, but it will be different transformers. So this is a different transformer, but it's the same rating of the transformers. So this is 132. Then we are also 132 kV. This is just to carry more power. It's like a bus carrying more passengers. This also carries more circuits, 2 circuits. That's okay.
So, doctor, can we say that we have two, so that let's say if line 1 fails, the second line could work as a backup for the line, or it's not?
Well, that will be okay. Yes,
relevant?
exactly. That is also the same thing that when you draw on the software, you draw 2 transmission lines. These are 2 transmission lines. Exactly. These are the 2 on the same tower. When you draw 2 transmission lines on the same tower. But mostly on the substation, when you see just 1 line, does not mean just 1 transmission line. They do 2 circuits. So we combine them together and you draw only 1 line. So most of the substations receive 2 circuits. In the PowerWorld simulator, when you draw 1 line, it could be just 1 circuit, or it could be 2 circuits. So but we draw them 1. Okay. Sometimes we want to emphasize also we need to draw 2 transmission lines. So these are 2 transmission lines. Okay, 2 circuits. Sometimes we draw only 1 line and it represents 2 circuits because we don't want too many lines there. But in general, you will see only 1 line when you draw. But in fact, it is a tower that carries 2 circuits. So when we calculate the power, we calculate the power for both. But you don't worry about this. So whatever is the power is written, you don't care whether it is carried by 2 circuits or by 1 circuit. So we don't care. But you're right. That is also an advantage of having 2 circuits. So if one fails for any reason, also the power is still there. So it is it is also so the power will go through the other lines. Okay, you're right. Also, one advantage also to carry. We don't say a backup, but that will carry if there's anything happened here. Also, the other power will go to this line. Okay. All right. Okay. What's the purpose of the damper? The damper is for the wind. So this will to move a little. Okay, for them instead of to be stiffness, so it could move. Okay. So for the sagging, so it is for the flexibility. Exactly, it's for them to be flexible. Okay. All right. And also there's a protecting angle here when they do this one here, of course, and the spacing here when we do inshallah the same when we go on with the same chapter here, there is a spacing here between phase 1, phase A, and phase B. So there is a space here because these are voltages, so we cannot make them very close to each other and not very far. So these spacings are calculated, okay, according to the voltage level. And we will discuss these later as we go on the chapters here by the spacings. And because we have these 2 conductance will be, when we talk about conductance and capacitance, where do we get these capacitance and inductance? Because these transmission lines are close to each other. You remember now when we talk about capacitance, there is no physical capacitor. There is no physical inductor. But because these are close to each other, therefore we have inductance or reactance, and we have capacitance. Okay, 2 wires close to each other, there will be inductance because of the flux linkages between them. Okay, these are AC circuits, so therefore you will have flux linkage between them. Then we'll have inductance. So when you calculate inductance and capacitance, you don't think you are calculating a physical capacitor or physical inductor. We are calculating these, okay, because of the spacing between them. Therefore, there will be an inductance and also capacitance. Okay, therefore we need to generate capacity. We need to calculate the capacitance and inductance, and we call them the transmission line parameters. Okay, that's what we discussed here, and okay, to protect against lighting, and that's what we already discussed. Okay, and sometimes this one here, for example, this, as you can see, this only carries one circuit. Carries only one circuit, and you can see here, if you can, if I can zoom in, this has 4 conductor bundle. As you can see, this is the bundle now. This is the wires, 4 wires here. So this has 4 conductor bundle. Okay, each phase has 4 conductor bundle, but it's one circuit. Because this shape of tower here carries extra high voltage. So this will be maybe 700 kilovolt or 400 kilovolt. So you will see only one phase. We cannot have two, because the spacing, we need more space. So there's only one circuit in one tower. There is no space we can put the other circuit here, because we need more space. But their power here will be also, this is 4 conductor bundle, 4, as you can see here. And these are the insulators, okay, from here to here. So that will be okay. So for each one, so we have 2, 3, or 4 conductor bundle. We don't have 6. We have 2 conductor bundle. We have 3 conductor bundle. When we have 3, we have them as a triangle. So the spacing is the same. When we have 4, also the spacing between each conductor is the same. Okay, مربع, as a square, as you can see here, square. So this is a 4 conductor bundle. So this is bundle conductors, 4 conductors. And this tower here, when you see a tower like this, means that it is extra high voltage. It carries high power because of the high voltage. Okay, this is only to give you more. If you have in your leisure time, you can have the difference between the dead end tower, supporting tower, and tension tower. So this is only to give you more about these. For example, here, like this one, we call it dead end tower. It comes here, and then that's it to the substation. So that is at the end. So as you see now, the tower is at the end, or dead end. Must be more stronger than a supporting tower. You can look at here, the supporting tower of this one here is just to support the transmission line. Carry on, okay? So it's just to support the transmission line. But at the end here, the strength of the tower, or the structure of the tower here, is different. And then it comes to the another here, the dead end. So this is a dead end, will be like this one. And then it goes here to the transformers. This is a substation here, as you can see. Yes, yeah, Muhammad.
Doctor, why between each within a bundle, between each conductor the spacing is less, but for between each phase the spacing needs to be more?
Because in each bundle conductor is the same phase. So even if they touch each other, there's no problem. This is one phase. It's not 2 phases. It's not separate. This is 2. It's big cable. I make it into 2.
Oh,
so it's
okay.
a phase, same phase. And what you see here, the spacers here, is just to make them the same. So they do not make them even. So even if they touch each other, there will be no problem, because the same phase. All right, good question. Yes, Anthony.
So, Doctor, can we say that in both lines the current goes on the same way, so they repel each other by
yes,
the effect of
yes, no, the same line. The same line is the same phase. So the current is the same. The current is just split. Instead of having 3,000 in each 3,000, for example, they're to be split into 2,000 ampere.
Yeah, but
yes, the current is the same.
But will it
Because
not
the phase is
short
different.
the circuit?
No, because these are same conductor, same connectors. You have two wires instead of having big wires in there. I can split the wires. So what is the problem there? The same. It comes from the same phase. From the same phase. So once you have the phase, how you can have the
Oh yes, I just
you
realized.
can have,
صح صح.
so they do not touch the neutral. They do not touch the other phases. So same phase.
Mhm.
So there is no short. Okay, good. Okay, thank you. All right, so you can also look at the structure here, and you'll see this as suspension carries two circuits. Once you come here, the dead end. Sometimes when we have it like this, we call it tension tower. That's at the end. Also, when we come, sometimes you will see there, then this will go maybe underground. Sometimes it's transmission line, and then once come to the city, it goes underground. That's okay, through a substation, of course. So it comes transmission line until it comes to the substation, and then it goes to the city underground, changed into cables. Okay. So now we have the electrical factors. So we have conductors, of course, that we want to what are the design considerations. So when we take it into design, what do we take here? What we have electrical factors, mechanical factors, environmental factors. When we design a transmission line, so with the design transmission line, we have to take a number of factors. So the part of it is the electrical factors. So about the spacing, as we mentioned, the size of the conductors, the type of conductor, is it, we will discuss at that time, because each conductor also has a separate, some of them are aluminum, some of them are aluminum steel reinforced, some of them are all aluminum. Okay, and these mostly are aluminum steel reinforced. So what you see is aluminum, and we'll come to the aluminum because it is light. Okay, the weight is light instead of having copper. Okay, but in the underground cables, they are made of copper. And of course, copper has higher conductivity, so the losses. But it's okay to have more, to have losses. But you see, this is the compromise of design. Losses in aluminum, it's okay, but it is light. So we want something light to go. It's very light. If you carry it like this, you can carry it. You will not. You barely feel the weight of the aluminum. It's very light. You can barely feel the weight when you have a transmission, and you will see very small. And this is 132 kV, for example. Okay, so what you take here is insulators, and we take the face-to-face clearance, as we mentioned, about the face-to-tower clearance. So there are a number of factors you will take. We call them electrical factors. Shield wires means the earth wires. That is the number, type, location, etc. So these are the electrical factors, and we have mechanical factors also. The strength. When we talk about mechanical, therefore we go to the strength, to support, to the steel, to the structure. Okay, you see now how things become now. The electrical with the mechanical, they come closer as we go to the power. Similar for the turbine. The turbine is taken care by the mechanical power. The generator is taken care by the electrical engineer, and they are connected to each other. You cannot run the generator without a turbine. So you need a turbine to rotate the rotor. Okay, so mechanical, and then we also have environmental factors also. We need to have also to take into consideration when you design these transmission lines, you take into consideration the environmental factors. So effect on the population centers, local communities, so land values. So because this is run in the land, as you can see, it is far from the road. You cannot bring it very close to the road. Okay, so you can see when you drive, for example, and you will see, so there must be a clearance between the high voltage or extra high voltage, and the communities or local or the population of the people. Okay, because these have a magnetic fields and also electric fields. Once you have a wire, it is electric field and magnetic field. The magnetic field causes the inductance, the electric field causes the capacitance. And also we take the economic factors, of course, the meeting the criteria with the lowest overall cost. Always as an engineer, you always think of the lowest cost. We're talking about optimum. We're not talking about the best. Okay, as an engineer, you are not selecting the best. We are selecting the optimum or the optimal. Okay, so you always, as an engineer, think of optimization. Okay, optimization. So you weigh the cost, the weight, the maintenance. There are a number of criteria you take care of it as an engineer. Okay, power losses. Okay, the lifespan, etc. So there are a number of. So we have 4 factors here: economic, environmental, electrical, and mechanical. And please try, when you ask to design what are these factors, please try to remember, at least to remember some part of it, to understand actually what we design. Okay, so please try to remember what are these. As I told you here, this is called the steel reinforced aluminum. These are aluminum, and this is steel to make it strong. So these are steel strands. As you can see here, these are called strands. Not each conductor is made of also of strands, small little pipes, as you can see here. Why? I want to hear from you. Why? You already had this somewhere. Why don't we have just a solid aluminum like this? We can have solid, but it is better to have, instead of have a solid conductor, we have them into strands, small.
To reduce resistance?
Skin effect, exactly. Okay, skin effect. So the skin effect. Why? If you make one solid, the current will not flow through all the conductor. If you have a solid, it will try to it will flow only at the outer surface. At the outer surface. Okay, so people will go at the outer surface. It's very crowded, becomes very crowded because of the electrons, of the electrons. Why it becomes very crowded at the middle. Therefore, the current will, when we say current is electrons, will try to go to the outer surface. Sometimes you see only a pipe, hollow pipe, and this is a conductor, hollow pipe. There's nothing inside. There's no need to put anything inside. Hollow. Like this one is what you see here. The steel, for example, steel will not carry that much current. Why? Because the current will flow out to the outer surface. This is the aluminum. So we're not expecting the steel to carry power. Although it is a conductor, but we are not focusing on this. We are focusing on the aluminum. This is where the current, most of the current will flow on the outer surface. And that's why. So for each small strand, there will be current, and then nothing, and there will be current. So therefore, you can divide the current into small, instead of having just one pipe and nothing in the middle. So we make them small. Therefore, the current will flow on this outer surface, no problem. On the outer surface, no problem, and so on. So therefore, you will see the current flowing through all the conductor. So we make them into strands. So we call them, this is called ACSR, aluminum conductor steel reinforced. So we put steel here. We put steel. And it is spiral like this. Why spiral? For strength. So instead of just having one full, we make it spiral. And when we calculate this one, sometimes we add maybe 2% or 1% of the length of the conductor. when we do calculations. So to account for this spiral, okay, because the length will be more. But this is for the strength instead of having one full conductor straight. And this is called all aluminum. What is this? All aluminum alloy conductor, or aluminum alloy conductor. All aluminum alloy conductor. All aluminum. So this is all aluminum alloy, no steel. This has steel. But so they mostly use this. Or this one. Okay, so they also use this one for, if you want more strength, then you will go with this one. If, maybe 6 kilovolt, this way you will go with this one. So even 132 kilovolt, they have this also. So these are all aluminum, and this is aluminum conductor steel reinforced, all aluminum conductor, or called all aluminum conductor without alloy. So this is another overhead transmission lines. So this is, you can search this. And as we told you, they are bare. There is nothing for heat dissipation. There is no insulation around these. As you can see, you have no insulation here around. No insulation at the outer surface. So they are just, but you cannot put them underground, of course. These are only overhead transmission lines. If you come underground, therefore, then we have insulation. The cable will have insulation. Okay, this is from your textbook here, the phase conductors. This is just to give you an idea, but nothing here, just 69, 138. By the way, in Qatar, we use 66, we use 132, we use 240 instead of 230. These are the American kilovolt. They use these. We use the 400 instead of 345 or 400. You see now they reach even at 765 kilovolt with 4 conductor bundles. So they go with the very extra high voltage with the 2 bundle conductors. But that's even in the 400 kV, of course, you will find. Even in the 220 kV, sometimes you will find two bundle conductors. This is not just worldwide criteria. This is, so even in the 220 kilovolt, you can find the 2 bundle conductors. But as you go high for 700, this you can find them in Japan, in USA, in China. We have very high. This is extra high voltage. You can find the 4 conductor bundles, and then also the spacing. So these are for the design, if we are going to do some design on this one. And the spacing also. These are the problems that you will be given: 7.6 meter to 11 meter. You see when we go about the phases, between phases and between ground. Okay, and these are the centimeters. You see now the bundles are even, 45.7 between one conductor bundle and the other conductor. Okay, this is one phase. So between these two, 45.7 centimeters. And between also the 4, 45.7 meter between the square, okay, between each. All right, the last thing, maybe the last slide here. So we have these called the transmission lines, parameters, resistance, conductance, inductance, capacitance. And the resistance, how we have the resistance is the area. Once the cross-sectional area is large, as you know, the resistance will be small. And that's why we use in air conditions, for example, you will have 6 millimeter. The wires in your house will be 6 millimeters or 4 millimeters if it is 1.5 ton. But in the lighting, for example, you will see 1.5 or 2 millimeter, but not centimeter, millimeter, 1.5 millimeters thin wire for the lighting. While for the oven, for example, you see 6 millimeter. That's in your house, 6 millimeter. The cross-sectional area. okay, to carry more current, and also for the resistance. Otherwise, it will become hot, and then once this becomes over hot, then you will get fire. Okay, so once you change your AC, for example, make sure that the conductor there, you cannot just change AC, for example, 1 ton to change it into 2.5 ton. So you need also the wiring. The wiring should support this one, maybe 6 millimeter wire will carry. Okay. So you need to change the wire also. If it is small ton, for example, 1 ton, and you change it into 6. All right, so I need to stop here because because the quiz is open for you. Okay, I open the quiz automatically, and you will not see your grade.